Ready.
Okay. All right. Welcome to this new episode of Neural Search Talks. My name is Sergi, as usual, from Zeta Alpha. Today is a very special day because we have an external guest and we have a bit of a almost experimental episode ahead of us. Let's start with the introductions as usual.
Yeah, I'm Andrew Yates, assistant professor here at the University of Amsterdam, working on neural methods research.
And secondly, we have
Gabriel Bénédict. I'm currently a PhD student in the same lab as Andrew, and I'm also collaborating with RTL, with the supervisor there, RTL Netherlands, and writing on currently on diffusion for recommendation and organizing a workshop about generative AR.
Yeah, I think that's the most interesting bit. You're organizing a workshop on generative AR for SIGIR in 2023. Right, and we're gonna get a bit more in depth about that. But before that, the reason why this episode is a bit special is we normally do episodes based on papers, and then we kind of go through them. But this time we wanted to talk about the bigger picture in language models in search, and a bit kind of like the high level of how information retrieval is being transformed or not. I don't know what your opinions are on that. And to do that, we kind of base a little bit our kind of scope and outline in this position paper called Rethinking Search by Donald Metzler from Google. I think this was in 2021. And then also more recently, the whole space of augmented language models. There's this very nice survey by Meta called Augmented Language Models, a survey, which I think is a kind of a good base that has a lot of references that are interesting in that space. Let's maybe comment a couple of news bits.
Right. So in the past few days, there's been quite some news with like user-facing LLMs, let's say.
You can say that. You can say OpenAI.
Yeah, this ChatGPT plugin stuff.
ChatGPT. I agree with the aversion to say ChatGPT too many times. It gets old and it's.
So in my head, I was still thinking about mentioning other stuff. No, there's one or two other stuff, right? So there's ChatGPT released plugins. They call it retrieval plugins, right?
Which is an interesting choice, right? Because it's not only about retrieval, or I wouldn't, like at first glance, I wouldn't say it's only about retrieval.
So I think in the academic information retrieval sense, I think it is. So basically it uses Expedia. I don't want to make ads for companies, but it's using Expedia or Instacart, and it basically retrieves from, Instacart products or Expedia the destinations you can go to. So I think it's a true retrieval system in the academic sense.
But I guess my point is, like, if you use, for instance, like in my head I had this plugin with Wolfram Alpha, for instance, right? Is that retrieval augmented?
Right,
because like Wolfram Alpha is kind of like a computation engine, or like, I don't know how you call it, right? Yeah. I mean, it is in a sense retrieving information.
Yeah, it accesses some sort of search type API, I guess is where the name comes from. Where Wolfram Alpha might just do a computation for you.
Yes. Yeah. And I think now it's on waitlist still. There you can both waitlist for make a plugin. You can build a plugin yourself. I think you write it in natural language. You write the API in natural language for your app. And there's also LangChain that had a retrieval.
So to give a bit more context, LangChain is it's like a Python library, right? Like to write some sort of like more complex prompt pipelines, I would describe it as, right?
Also chain of thoughts.
Chain of thoughts as well. Like the idea is kind of like to have a higher level sort of library to program in this prompt paradigm, I guess.
Yeah, totally.
And they introduced this.
And they introduced a retrieval module, which already existed a few days, maybe even a few weeks ago, and now they basically integrated with the OpenAI ChatGPT retrieval thing. So just to make sure that they're very fast. Like LangChain is extremely fast with delivering, so they already adapted everything ever since ChatGPT came out with their plugins.
Okay, that's it. Like, let's take a step back, and I wanted to start this conversation by kind of like asking Andrew to make a bit of a reflection on the sort of foundational principles of information retrieval, or like to basically break a little bit out of the box of thinking information retrieval as a query box on Google, and like more of the broader scope of what information retrieval is and what it tries to achieve? And
yeah, I mean, so at the end of the day, or maybe the beginning, information retrieval, you're trying to connect people to some information that satisfies an information need, right? So of course, one way to look at this is that box. You type in a query, you get some links back, you look through the links, satisfy your need, and you know what you want to. There's also other ways to look at this. So if you think about like the Rethinking Search paper, question answering is a really common one. And here, this is quite straightforward if you think of a simple question, because now rather than pointing someone to that link, you can just give them the answer. Like how long does this vegetable last in the refrigerator? What is the celebrity's net worth? Anything like that. It's just you enter in a few words. Mm-hmm. And so you don't necessarily need to retrieve the link. Or maybe you do need to retrieve it. You don't actually need the user to look at the link necessarily. You could just give them the answer directly. Mm-hmm. And there are other sorts of information retrieval problems like this, I suppose. Like if you look at recommender systems, if you're reading a news article, maybe there's some retrieval problem there where you want to find similar news articles, so there can be a pane on the side that shows you, here's other news articles with similar content that you might be interested in. This is like a content-based recommendation. You could also have neighborhood-based, looking at user patterns, but this is, I think, moving away a little bit from search.
Mm-hmm. So in this position paper, Rethinking Search by Donald Metzler, they sort of summarize or kind of like try to capture the existing research up to 2021, more or less, in these 4 pillars of document retrieval, question answering, explicit knowledge bases, and pre-trained language models. Could you just kind of briefly sketch what that means, and maybe like even if you have a bit of a critique or say like maybe that doesn't capture well what happens.
I think we've hit on the first 2. Explicit knowledge base. This is you explicitly know some facts, and so I guess you can retrieve a fact in response to what the user asks. Like a knowledge graph
type of thing like this.
Yeah, to me this is moving into more of an ingredient for question answering, but the paper, I think they have a specific way to look at it, that it remains separate. And then pre-trained language models here.
I mean, we've talked about this at length.
This is fairly different from search traditionally, but maybe the language model knows something.
But I think that very much links into the next point is like language models are kind of what you would call models, right? And in this paper, one of the big kind of distinctions that kind of the paper is built on is this idea of thinking about retrieval from an index-centric perspective versus a model-centric perspective. So can you describe maybe to the best of your knowledge what Donald means by that? And maybe we can try to like figure out what falls into each of the categories. Yeah.
So I can try to give an impression. For me, my impression is that model-centric is somehow the information is hidden in your model weights, right? You have a model and the information is hidden somewhere in your model weights. What is the date when Napoleon was born? And that's somewhere in your model weights. Whereas index-centric is you still have to first check in Wikipedia, in encyclopedia, whatever that is, when was Napoleon born? And you have to go and read it first. I think that's the main difference.
But I feel like, then do you think it has something to do also with the interpretability of it? As in, like, could you make the index-centric is interpretable in the sense of you can kind of like see where the knowledge is coming from, whereas in model-centric is more of a black box, or not necessarily?
So I think people are working now towards making these model-centric ones less of a black box. And there are mainly two kinds of way. One is to do it at training time. So somehow while you train these model weights to contain information, you also make the model learn how to attribute, how to source where it found information from. Or there's a post hoc way where you first write a full answer and then you try to figure out where did that answer come from. And then there's something in between, which is you teach the language model to query an API, the right API for the right question. It's a bit similar to actually that ChatGPT plugin, but there was a paper before that.
But this is no longer even model-based. You're using an external inverted index or something to query, which is fine, but we already are thinking about a model-based model that's no longer model-based.
Yes.
Which is fine, just pointing out
that is not so clear cut. So like, for instance, if I give you examples, I mean, I guess like something like when you do BM25, it's pretty clearly some index-based search,
Yeah.
right?
Yeah.
If you use something like Colbert, where you have like pre-computed index, that would be
I would
pretty much
say it's still an
like
index,
dense
yeah.
retrieval. You use a model to encode documents.
Docs.
It's not fully interpretable what each of those vectors mean. I mean, you can have some ad hoc and some.
Yeah, but you still know which vector belongs to which document.
Yeah, correct.
Your index is storing dense representations rather than sparse ones. With BM25, you have a sparse representation over some term.
You still have a mapping between like
Yeah,
document
yeah.
to, so it is kind of somewhat interpretable, but I don't want to get into like the rabbit hole of the
the level of where something came from is interpretable, but not what's in that representation. Now, if you move from the sparse to the dense index,
then something like a re-ranker would still be. I mean, in a re-ranker, you have the two steps, right? Like the retrieve and the re-rank. That would still be considered index-centric in this sort of line of thinking.
I guess so.
Right? And then when you would have like something that would be clearly cut, generative, model-centric would be like a fully parameter, like ChatGPT, basically.
So, for example, if you ask ChatGPT, without a plugin, without anything, you ask GPT, when was Napoleon born? And it gives you an answer. For me, that's purely model-based because it's in the weights.
Okay.
It's not going on the internet. If you ask Bing Chat, it's going to go on the internet. It's going to look for it. So I think that's in a very, very naive way. For me, that's the difference.
Okay. So like, what would it be for you the main critique or kind of like or like the main thing that you say, okay, this is not really a useful angle to look at things?
The main difference from me, I think, is very similar, that is we no longer have this explicit inverted index, and I don't see why we don't want an explicit index. I think everything is better if we have one. I think these models have their own ways they can improve things. I'm not at all convinced that getting rid of the index is one aspect of that. I think they have way better query understanding, way better incorporating of context. Things like this can help.
Okay.
Removing the index is something I don't quite understand.
Okay. I mean, and like we talked about earlier, this paper is from 2021, right? And you said like a lot of things have changed. And I think that is a good time to introduce like this whole, I think like both the new terminology, I guess, about generative IR and this workshop that you're organizing, and sort of like try to pitch it, like why that makes sense, or why is that a better kind of label to call these things, or like a better abstraction or a better...
Cool. Okay, let's try. I think first disclaimer is we're not trying to be assertive. We're not trying to be pedantic and assertive about words and labels. Especially not me, because I recently went into IR, and I don't think I'm a legitimate person to start saying, oh, we should rename this or that. I think it all came about because we just had an impression that there was something happening, right? Even after receiving research, that there's just something happening with people trying to do things in the same kind of direction, and we wanted to find a way to give a name to it. Given everything that's happening with image and text being all around generative models, and that feeling that there is something generative about this whole movement, we felt like calling it generative IR. It's something that my supervisor, Martin de Rijke, got on board with, that Donald Metzer got on board with. It doesn't mean that it's going to stick for, it's the crowd that's going to decide.
What is then? How would you define what generative
okay, so let's get to it now. So generative IR, that we define it, mainly we say there's two main topics. So one is the grounded answer generation, and the other one is generative document retrieval.
Okay.
So grounded answer generation is generate an answer, a full-fledged answer that somehow is grounded in some outside truth that's written somewhere. It could maybe actually not, it doesn't have to cite its sources.
Okay.
Per se, but it has to be grounded in some external source. Ideally, for sure.
So it like something that's fully parameterized would still be in this sort of framework considered grounded because it has been trained on...
Exactly. As long as it doesn't hallucinate.
Okay.
right? Otherwise, it's not grounded.
But if you can't cite a source, there's no way you can distinguish between hallucinating versus actual grounding, right?
Yeah, I feel like this is an interesting topic. I'm not sure it has been addressed. I think there is some of the retrieval, the so-called retrieval enhanced or retrieval augmented large language models that do grounded answer generation without attributing, so without giving the source. That exists, but
in what sense can you like
retrieval augment?
No, I mean, in my mind, grounding was synonym with citing. I guess that's what I'm. Like,
so we're trying to mean just that it's grounded in somewhere in truth.
Okay.
I think most of the papers. I think you'll find just most of the papers that do grounded answer generation. They try to cite the sources. That's the main point. Also, because it's the easiest thing to think about.
I mean, so like, would it be fair to say that it's pretty much retrieval augmented language models?
Yes.
I mean,
or they also call it.
I mean, you don't want to kind of like box it too much so that like something else doesn't like kind of fit into the label, right? But or more or less.
So it's retrieval enhanced LLM, and they also call it attribution for LLMs.
Okay.
Which could be argued are two different things or not. I think we can get into that later. Then there's generative document retrieval, which is also a word that comes out of nowhere. But what we're trying to say here is either you generate a document ID as an identifier.
I mean, I think it's just useful. We did an episode on the differentiable search index.
Yeah.
I think that's
the DSI.
I'm pretty sure that's kind of like the first one that really showed this idea of like generating a string identifier that was not semantically relevant. It was linked to this also like autoaggressive entity linking, I think.
Right.
Yeah.
I think it's one of the first ones there is arguably an ultimate retriever corpus with a model-based indexer, but I think it's definitely.
Which was similar. It's basically like this idea of like where your model acts as an index, right? Like you give it a query and it returns an ID, like a pointer to something in a database.
And somehow this is in the model weights, right? Like it figures out the ID in the model weights. I think we'll get into how it's actually not completely end to end, but it's somewhere in the model weights.
Yeah.
You do have to do a little bit of something after at inference time, but it's in the model weights, and it doesn't have to go and cycle through Wikipedia to find something.
Why do you want it to be in the model weights?
So something that I quite I do agree, like the DSI paper to me seemed like super interesting conceptually, maybe not so much from a sense of like this would be useful to replace many things. It just like seems like a very niche use case, but to me maybe the most interesting part was its potential in self-supervised learning for IR, or this whole idea of using these techniques of contrastive learning, of like using a bit of a document to retrieve the document ID or things like that, and how that translates into the sort of like the end task. So basically train some model to retrieve stuff without supervised data. It's not like they had super strong results, but it seemed like a something that could lead to.
Don't they train with relevant annotations?
Yeah, they do, but they do some experiments without them. I guess that was my point.
No, I get it. This is also what I think about when I think about these sort of LMs for IR. It's this that I think is most promising, right? So these are really strong models. They're really good at understanding some text. So I think of this as the advantage. Some ability to maybe change domains with minimal training, some way to use a lot of self-supervision for IR, right? These are all things that are a bit different than whether or not you need an index, where the LLM can help a lot. Or think of like ChatGPT. It does really, really good query understanding. Like it knows what you're looking for, and from its parameters, it comes up with an answer. But if you had that query understanding, why not pull it from an index? Right?
Which is what Bing Chat is doing.
Yeah. And I mean, I guess like you could also make. Like trying to argue a bit more from the like, let's try to reinvent search or something like that. Don't you think that a lot of the benefits from using traditional inverted index come from the fact that these are kind of like technologies / data structures or something that has been around for many decades, and like people have engineered a lot of kind of things around that, and like they're understood very well, and like they work so well because there's such a body of knowledge that has been built upon that. Whereas when you look at generative IR or like model search or like these type of things are just very kind of like brittle and very early stage and like you know what I mean?
We also have like FICE and vector indices. So these have also been thought about, I guess, for...
What do you mean? Can you...
Well, we have like the FICE index, right? So there's an inverted index, but with dense retrieval, you also are using, this vector index. You're storing document representations in an index that will support approximate nearest neighbor retrieval given that query vector.
But that's still index-centric.
Yeah, that's what I mean. Just that there are different types of...
But not there's not the equivalent for like model-centric retrieval, like for DSI type of things.
Well,
right?
There can't be, because an index by definition, you have a symbol as input and it gives you a symbol as output.
I see.
Right. So model-centric, you can do something like that, but if you create a symbol, then you're manually going to feed that into an index, I think, right? Like it's...
Yeah, I think also the problem with model-centric is that it's completely dependent on your training set. Like it's very proprietary. Like like there are now startups that do index search for you, right? I'm not sure it's possible with the end-to-end model thing, because then suddenly you need to share the weights of the whole model. Like in the index-based paradigm, you can share just let's say the embeddings of all the documents, and then someone in a later stage can use these embeddings to actually with their own queries figure something out. I think in the model based, it's like you need to share everything. So maybe there's less of that relationship.
All right, so like if you're trying to recap a little bit, basically in generative AI, you could say you have two main flavors, right? Like the generative document ID, something like DSI, you give a query to a model and then black box outputs an identifier for a document that can be an ID that's not semantically relevant, but could also be a title, some bag of words, something like that, right? Is that fair?
Totally.
And then the grounded answer generation, basically something like retrieval augmented language models.
Yes.
Right, and you could argue as well that fully parameterized language models are also of some form of that. There's a question of grounding that's kind of a bit right, and hallucination. Cool. Are there other sort of flavors of things that that would still fall under the umbrella of generative IR?
Yeah, so we're trying to attract people to submit things about any other topic, but we mostly found three topics with a single paper in that domain. So one is generative recommendation. I think it just came out 2 days ago. It's a Google paper about using IR concepts for recommender systems. So it's literally called Recommender Systems with Generative Retrieval. Haven't read it yet. There is, although we've been discussing it because the word was out there. Summarization. There's also people who are looking at how to summarize. I think it's something that you can make ChatGPT do, or any large language models. But there are people who focus on that summarization. That's grounded in knowledge. And then the last one is knowledge graph generation. So literally try to force a large language model to retrieve a knowledge graph about a certain topic. So you give it Napoleon, and maybe it gives you its family, where he did battles, etc., etc. And any other things you can think of, but that's what we could find.
I guess I'm thinking about your original definition of IR, what IR is. I normally think about summarization as an NLP task, right? But I guess it's a good example of things kind of get a little bit blurry, like the lines, right?
I think there is one sentence that I think my supervisor would kill me if I said it, but it's like maybe it could consider it's like ChatGPT that doesn't hallucinate and cited sources. Maybe that's what generative IR is in a lot of ways.
Okay.
But maybe it doesn't summarize everything either.
All right, let's try to move on. I wanted to make a couple of points about retrieval augmented language models, because I think that, let's be honest, that's for now the bulk of the interest. I would say two people. My mom doesn't know that it's retrieval augmented language models, but she knows what ChatGPT is. or like actually not probably not the Bing, but anyway. So I think it was around the 2020s was the first retrieval augmented language models, right? So something that I would like to highlight about retrieval language models is kind of the main flavors of how to incorporate knowledge into their generation. So maybe Andrew, you can just quickly sketch that.
Yeah. So these early ones like Realm and RAG, they're basically doing retrieval from some sort of index during training, retrieving something from that index. So imagine some sort of dense representation, and then using that dense representation to generate the output. So I don't know, maybe the dense representation gives information about topics or even specific terms, but their output is now conditioned on this dense vector they've retrieved in addition to the input. So this is, of course, part of the pre-training, and they train these in different ways, but that's I think, the gist of it. Maybe I mentioned the other strategy, which is to retrieve and then include it in the context, right? So with like Bing Chat or ChatGPT, what you can do is you can issue a query to Bing or some search engine, and then just copy paste whatever output or whatever is returned that looks useful back into the context that it can then use to answer the question. And so this is a very different flavor, right? Because there's no pre-training happening, or I assume they're not. As I explained it, there's no pre-training. It's separate retrieval.
I mean, my opinion on this is, I would say I'm way more interested in the second sort of type of augmentation. Like it feels to me like a way more kind of plug and play, or like robust, or like more useful thing to do things. And it seems like ChatGPT, different, like these plugins that you mentioned at the beginning, that's how they do things, or like Bing. Do you agree with this sentiment, or do you think there's still kind of like a case for cross-attention, something a bit more involved pre-training, including information retrieval?
I think it would be cooler. It would really make it end-to-end.
Cooler in what sense? Like the nerdy sense?
I guess so, yeah. I guess the idea that, you know, the weights can both contain things about reasoning, logic, etc., as well as knowledge, and somehow be coherent in its answer. But the problem is here is, I think the main issue is with this paradigm is you hit the problem of what's a big group of researchers say, that autoregressive LLMs will never be able to not hallucinate. So you can try to make LLMs learn about a lot of concepts, like what is knowledge or what is logic or reasoning, but it apparently it's hard to make it learn to be very deterministic about certain things. There's just certain things that we as human things are deterministic. We think that Napoleon was born on that day. And
I don't know.
Nobody wants
to
disagree. No, I don't know either.
Whatever day it was.
I don't know why I chose this example.
Well, we criticize the language model for not knowing that.
Yeah.
Well,
this is coming from your parameters. We need some attribution. So on.
Yeah. But somehow we can't really force the language models. Or I was playing around with GPT-4 just an hour ago with my colleague, and he said, look, you can't even make it describe the beats in a song. So we put on a song and we said, can you describe the beats? And he plays the drums, and he says, yeah, that's nonsense, right? So it's the kind of things where we humans, we think that for these things it's very deterministic. Like there's particular notes that are played in songs, etc. And somehow we haven't found a way to make large language models or any models for that matter to be very deterministic about certain things and probabilistic about others.
Okay. So I guess like your point is more about lack of reliability.
Yeah.
Would you like to add something, or also on the point of like how you do augmentation, retrieval augmentation, or grounding in language models?
Yeah, no, I also like this idea of adding to the prompt. But one thing I think about, if you come up with a dense representation, it's a bit odd to attend to this during training, in the sense that, have you really preserved all the text in that dense representation? It's probably possible with some really large size, but I wonder why not attend to the original text rather than trying to add this bottleneck in the middle, this sort of thing. But so I think what I like about the flavor is attending to some text, because this was the original representation. Nothing's been lost. A human came up with that representation, and then internally can change,
Okay, so one of the interesting bits to kind of think about this is to look a bit at the contrast between what's interesting to study from an academic perspective versus what's interesting to study from the commercial perspective. So I would like to study from the academically interesting, what's interesting about retrieval augmented language models, chatbots, all this stuff. And one of those topics is hallucination, right? Then could we define what hallucination is and like what useful types of, or like, I guess like there's the open and closed hallucination types that are, I think, a useful way to kind of like frame these things. Can you maybe describe that?
Okay. So I guess we're going to say that OpenAI owns the definition.
We'll give their definition. How about that?
They were the first ones, right, to sort of discuss
Maybe they
this,
were the first ones.
Or was it maybe in the context
remember.
of machine translation? I think that's a very also...
Yeah, there could be something much older,
a
but I
very
don't know
old
offhand.
concept, like this whole idea of how much you adhere to the original text versus how much you hallucinate.
Yeah.
But anyway, sorry. Go
So
ahead.
in the very recent GPT-4 paper, which is a paper that outlines what they do.
Well,
it's a long paper.
Yeah, paper is
Exactly.
a stretch.
Yeah,
It is a
it is
PR
a stretch,
document.
yeah.
outlining
PR
what they do.
document. I was trying to explain that it's a special paper. It doesn't tell you what's the data set.
It's a PDF.
It's
Well,
a PDF.
So there's
PDF.
a PR release about GPT-4.
Yeah, it could have been a blog post or something. Let's say the blog post PDF. They include a little bit of stuff about retrieval actually, and apparently they've fine-tuned or RLHF'd on retrieval. We can talk about it after. But first they define why retrieval is an issue, and they talk about hallucination, and they say there's two types of hallucination. There's open domain and closed domain. So closed domain is, for example, it's all about the prompt. So you give it a prompt, you say, here is a whole law article, can you please summarize it?
Mm-hmm.
If it gives an answer that doesn't correspond to the original text, then it hallucinates in a closed domain way.
Okay, so you're like, so this document is part of the prompt. In this case.
And then open domain is basically anything else that's not part of the prompt. Most of the time it's Wikipedia. So you ask a question to GPT-4, ChatGPT, whatever model, and it says Napoleon was born in 2005. And that's hallucination because it doesn't correspond to what's written.
Mm-hmm.
And then we can get to more things about, maybe you want to talk about it like factuality and faithfulness.
Well, let's say for a second on this issue of hallucination. Like, so I mean, it's obvious why this is a relevant sort of issue when you deploy these things into products and to general public, right? But from more the academic perspective of like what is interesting to study, well, first, do you think it's an interesting distinction to make, like this kind of closed versus open? And then what do you think is more... Well, do you think any of the two can be solved meaningfully? What would you... I don't know. What do you think is most interesting?
I mean, part of the reason probably why hallucination is interesting is because it's a very difficult problem to solve. Like, this is not going to be solved easily, I think, as we have now seen. I think connecting to faithfulness, hallucination is you have some input that should be used to produce the answer, and the answer is not faithful to that input. So you have Napoleon's birth year is 1291. I know that's incorrect, but the model should output 1291 if that's what it was given as input, regardless of whether this is factual or it supports anything else. It's just not faithful to that input it should be using. So this would be, I believe, closed domain hallucination is what you called it?
Yeah.
And then open domain is just you don't know where the input is, but you expect the model to have this input, right? It saw Napoleon's birth year, so it should be pulling the fact from wherever Napoleon's birth year is stored, assuming it is stored.
But then how related would it be? How related would hallucination be related to alignment? As in, like, when a model does something completely different from what you asked it to do, but it happens to be right. Like, say you ask, when was Napoleon born, and then it starts making a summary of of the Wikipedia article for Louis Armstrong and something. in the end, all of that is correct, right? That's hallucination, right? But that's kind of coming more from a place of misalignment. Is that a completely different, or like to your understanding, is that a completely separate issue, or does it still fall within the umbrella of hallucination?
I think it depends how you try to solve the problem of alignment, maybe. Yeah. If you give it instructions and it's not faithful to those instructions, maybe there's something like hallucination happening. I don't really know the contours of how precisely define all of this, but yeah.
I think the issue is, I think we can quite clearly define, or I can quite clearly define hallucination, I feel, at least in my mind. Alignment, not so much. Yeah. Right? I think alignment, there's a lot of stuff about things like toxicity, about...
Yeah. So I think like the next kind of natural point to sort of connect it to is the point about factuality and faithfulness, right? So how is hallucination related to factuality and faithfulness? What are those terms? Because I think it's a bit counterintuitive, or at least like I had to kind of sit down and think through it myself to like.
Yeah, me too. Like a week ago, I thought it was something different.
So please go ahead. When we talk about what
okay, so I'll give you at least the definition of people from our lab, from the IR lab, I guess.
Okay. The
official
one,
definition
like the
from the IR lab of faithfulness, I think, means you make sure that what you say as a model corresponds to something. It can be in the prompt, it can be anywhere, it has to be somewhere. Factuality is something that's not only faithful, but also corresponds to an overall truth.
Yeah.
So it's really just faithfulness to a trusted source, I think is what.
Yeah. I guess that's that's a very good way to put it, right?
Yeah. And then we can mention the issue of what do you do when it's facts that are less universal, like things that people don't agree about.
Mm-hmm.
What is the optimal calendar we should use? Should we use the lunar or the solar calendar?
Mm-hmm. Factuality is you're kind of like you're coherent with the ideal world, or like a kind of a source of truth, of like objective truth. That is factuality.
Yes.
Whereas faithfulness is you are coherent with the data that the model has.
Yeah. And right? I would even say there's only faithfulness, there's coherence with data. And if that data you believe to be truthful, if it's trusted data, now you're also factual. But from the model's perspective, I think it's really just faithfulness. Does it agree with some data or not? Right? There's no outside world for the model to reason.
Yeah. So you could kind of like split factuality into like the step of like faithfulness, whereas is it faithful, and secondly, whether if that source of data is kind of what you would consider kind of truthful to the objective world, or blah, blah, blah. Yeah. And I feel like that's so, okay. So I guess why I think that exchange is very interesting is that my assumption would be like, academically speaking, it's very interesting to study faithfulness, but when it comes to factualness, that's when a lot of the kind of nitty-gritty disagreements about like what humans believe, or like things are like kind of like more ambiguous. That, of course, like if you apply this in a commercial product, that's very important, but like academically speaking, I would expect it to be less interesting. Like, do you agree with that sentiment, or?
I do. I think if you solve faithfulness, then you just ensure you're faithful to Wikipedia or whatever source you pick, and you've gotten very far, but of course not all the way on factuality.
So I think, and actually our group is interested in that. There is another thing, so you can make it even more complicated, where there's also an academic interest. So imagine you ask, when was Napoleon born? Mm-hmm. You can answer in the solar calendar version or the lunar calendar version. Mm-hmm. Both would be faithful. You could argue nobody cares about the lunar calendar year and date, right? Except maybe a few religions or something, mm-hmm. or maybe a few societies, a few parts of society.
Some.
Exactly. And even some. So you could argue it's factual because most people care about the solar calendar. But you can see that even here you can actually start a debate. Mm-hmm. And so the thing that some of our group are interested in is how do you deal with faithfulness if there's actually several forms of truth? And you see that even with something that seems so clear as Napoleon's birth date, actually maybe it's not that clear. Actually, maybe some people would like to get the answer in the lunar calendar version. So,
I mean, I guess the answer to that kind of goes a bit of on a tangent, but then like maybe the answer is just personalization, right?
Yeah, or say which calendar you're using,
or like,
and then you're always correct.
But then you
then have to convert, but you're correct.
But you have that hellscape of like,
so what
you can end up with systems like everyone has their own truth, their own version of truth, and like.
So that's one way, and the other way that they're researching is maybe you should give a good amount of attention to each kinds of truth out there.
I see.
And in your answer, you should be balanced. And maybe even for such something that seems to have an evident answer, maybe even there you should have here's the solar calendar date. By the way, if you're interested in the lunar calendar date, click here. At least, maybe even if most people are interested in the solar calendar date.
I mean, it's interesting because like it's like interesting at the same time. It sounds like a very close to a philosophical discussion where it's like very hard to make meaningful progress in, as in like how do you like what is meaningful progress in that sense? Like should you choose this or that? It is very much questions about value and what should you do, right? So.
But then what's interesting is maybe there's a way in the model weights to read, how many times has it seen examples of solar dates versus lunar dates. And maybe out of that, you could deduce, okay, I should probably tell the solar
amount of weight.
A certain amount of weight.
Yeah, but this is also how you would get hallucination if you ask for the lunar date, because that popularity bias of the solar date will possibly outweigh that input asking for something else.
Yeah.
But
I think this is a good sort of segue into the question that I'm very interested in, which is evaluation, benchmarking, evaluation, and in a broader sense, sort of characterizing the behavior of language models, augmented language models, or like language models that act as a retrieval, information retrieval system, right? So I think a good place to start is maybe. So I guess like why is it interesting, right? Like it's kind of an open-ended type of question answering where you have for one query, like we've been talking, there's many possible answers that are quite correct. Then there's the issue of first, how do you annotate that? How do you benchmark that automatically, right? If you don't want to have humans kind of labeling how good outputs are for every query, which is very expensive. And secondly, more this kind of like part of discussions about what should be the answers of a language model. So maybe Andrew, you can give a bit of a historical perspective on like what people have done, or like maybe a couple of the metrics that people have used to solve this issue of open-ended question answering, or measuring open-ended quality of open-ended question answering. And sort of like the pitfalls of that, like what do you think will happen in the future? Yeah,
I mean, some of the difficulty with open-ended question answering, basically, as you said, you don't know exactly how the correct answer should be written. You can recognize correct answers, but there's more than one because it's probably natural language unless it's the most simple of facts. Mm-hmm. And even then, there's possibly ways to say it differently. So, I mean, people look at things like the exact match. This obviously has trade-offs. It's only true if it's exactly right. There's things like the blue and rouge scores. These are like looking at n-gram overlap, unigram overlap. There's a lot of variance, but looking at words that are in common between the correct answer and the generated one. Mm-hmm. If the correct one is France and you say, I don't know, some other country, then there's no overlap. This looks pretty wrong. Then there's also language model-based variants of that, right? So there's things like BERT score where they're trying to use a language model to look at the agreement. And then with large language models, I think Gabriel knows better than me, but there's more recent stuff like this. I think constitutional AI, they do something like this, where they're asking a language model to kind of evaluate whether this looks right.
So I guess like one of... I'm very interested in the whole space of like using language models to evaluate other language models. To me, it seems like you're just always trading off. You're just basically making the trade between how interpretable a metric is and to like how well it correlates to human judgment. I mean, I guess the case for these metrics is that they correlate much better with human judgments, right? Like the automatic metric compared to the scoring. But you always have this problem of like, it's more of black boxy. Do you think that's an inescapable trade-off kind of that we're gonna have to?
Well, big companies that have a lot of money, they escape it by doing RLHF, right?
Well,
they have paying a lot of people to annotate. and that's probably the best escape, because there's just things that are too subtle to pick up. Sometimes it's not about, you know, how similar words are in the answer versus the query or the document or the original document. It's not about does the bird embeddings look the same. Sometimes there's like some logic, some reasoning in there, or a date that's wrong. Like the date that's wrong is not going to get picked up. I don't know, because there's going to be other words that are different. So I don't even know how you would pick up a date that's wrong.
So if you were, maybe Andrew, this is a question for you, if you were to make a prediction on how the landscape of academic metrics, or like things that people use to evaluate open-ended QA will look like 2, 3, 4 years down the line, where would you?
Oh yeah, that's a good question.
I mean, I know it's
I'm tempted to say nothing will look any different, but it's hard to say. I mean,
you think it will look just the same?
I don't know. Maybe. I mean, we already know how to use things like BERT score, and we already they're not at all. They're a step in the right direction, but it's not a replacement for any other type of evaluation. If I were evaluating a system like this, I wouldn't think more about how to do the open domain QA. I'd think more about getting correct attribution judgments for the things I want the system to be citing, checking those judgments separately, and then checking whether the attribution the evidence is correctly summarized in what comes out, right? Looking at multiple steps in the pipeline, rather than trying to do an end-to-end answer comes out, looks correct type of evaluation. Mm-hmm. That's how I personally would think of it.
So there's one more thing that people are doing now, and that's the advantage of quadrant answer generation. So being able to really give out full natural answers is people are using tests made for a human to benchmark these retrieval models, right? So they make they make these models pass bar exams, pass yeah. I mean, the advantage of that paper, that I can find the name again, where they train an LLM to query APIs, is that if the LLM uses the right API for the right thing, then it's deterministic suddenly. Suddenly you query the API, the Wikipedia API for the date of Napoleon's birth, and then it looks into the Wikipedia knowledge graph, and it's gonna just be correct. Mm-hmm. So that it's a nice way to disambiguate the two problems.
Yeah, I feel like that kind of relates to like one of the spaces that I feel a lot of people are interested in the space of like language modeling, a bit more than information retrieval or like retrieval augmented language models, is also space of kind of like embedding language models into some form of formal environment, like a formal theorem provers for math, for instance, in where there's some training loop where the language model gets some signal that has some guarantees that is being correct. For instance, like a language model that generates code and then it kind of runs and then it kind of matches if the output is correct, you can almost not certainly, but you can kind of have a good guess that the procedure, right, like the program that it generated was correct. And I feel kind of like it's kind of related to that, and I would expect a lot of work in this sort of direction to emerge. But this is a bit of a tangent. What I wanted to sort of pose as a next, also kind of going a bit on the philosophical tangent of the evaluation challenges of language models is why do we even need to measure their quality do you have any, like, does that make you want to say something, or should I continue with my own?
If you can't measure it, you don't know if it works.
So I don't want to say that I could be on your side as well, saying that if you do, we haven't described formally what is RLHF or is RLAIF, but if you do that, and maybe having overall, like maybe you care about saying this answer is good, this answer is bad. Maybe you care less about knowing how the overall is, because maybe you get way further by just getting metrics on a particular answer, whether that's with humans or robots, getting better given this answer, and moving on, always learning. Whereas like the overall metric paradigm way more has to do with saying that a model is at some point finished, and that at some point we want to evaluate that model that's finished.
I guess something that kind of relates, or how I would understand, if I'm understanding you correctly, is you can always, instead of like having some absolute metrics, you can always do comparisons, right? I feel like that's one of the big difference between commercial versus academic type of systems, right? In commercial search or commercial stuff, you're pretty much only interested, is this better than this, right? Whereas in I think in academic search, you're very interested in saying, I built this and I want anyone to be able to replicate this, and I want to be able to compare it to many other systems that are more like a frozen snapshot of something. And it does feel to me like you kind of inevitably lose a lot of nuance when you try to measure a system in this kind of like, you try to characterize the behavior of a retrieval system into a single MRR number.
These sound like the same thing to me. So I think maybe I'm wrong, but what I understand you not liking about the academic benchmarks is they just have poorly chosen comparisons, perhaps, right? This is a frozen benchmark. At some point, maybe the examples you're looking at are quite meaningful. They become less meaningful as people work on that benchmark for a long time. In industry, if you're doing comparisons, you have to pick which queries or which examples to compare, right? IR, sure, it's a query or a question.
Well, I guess my point would be like in industry, you could just get click data or something like that.
Yeah, but like clicks are biased. Click data doesn't. You have to debias it, and how can you know that debiasing it works without having something to compare it to?
If I could go back to like the point I would make. So like let's if I would try to make the point that that metrics are not that they're bad, but I guess my point would be like. Highly opinionated, is like you lose so much nuance, right? When you try to compress whatever behavior into a number, right? Yeah. And I do feel like in science there's very much kind of a strong push or necessity to kind of like convert things into quantitative kind of data, and there's not so much focus on the qualitative analysis of how things behave. And I guess like my general sense is like I get a much better understanding of how a language model behaves by spending a couple of hours interacting with it or like trying to break it, rather than running a lot of. I mean that's a highlight. I mean it's. And I don't want to kind of like completely stand by that statement, but I guess my point is like you gain so much more knowledge by just having a qualitative description of how things seem to behave, rather than attaching that number to it, which kind of has this kind of hint of objectiveness.
The problem I see here is what's being done with the number. The number is not the end. The number is the beginning, where then now look at the examples where it's working or not. Now you have to convince a student to do that, which is where you see the perceived difference, right? But this is not the end, that metric. This is just the beginning of understanding what's going on.
I mean, that's the ideal case, right?
Yeah. No, it's the scientific case.
But like, don't you think like that papers often like contain like analysis on the numbers, not on the contain more analysis on the number rather than on the anecdote or like the sample. Which I think is the most interesting. Like you said, like the most interesting bit is like going to where it failed and then seeing what happened. Yeah. Not the number, right? I guess that's.
But I think part of the problem is it's hard to explain why it fails looking at examples when you have such a complex model. It's not necessarily possible. I think if you go back further, there are more examples of pointing to specific failure cases. And now we're using some large language model. Like, what can we say about why that failed? We could point to something in the data, except we don't know that for some of them.
Yeah.
I don't know. You could point to things like there was too much information in the context, therefore it couldn't incorporate it all. Something must have got lost. You know, it has 8,000 maximum context. There's 12,000 here. Mm-hmm. That's why it forgot this. But it's really hard to come up with some interesting normal case, right? These are all kind of corner cases that something was wrong in the data, something was wrong in the input. But like a systematic failure analysis for a model like that, it's not easy if possible. It depends on the examples, I guess.
And I think also the other aspect is there's so many competing models for the same task or the same kind of task that's why people are benchmarking on numbers. Because they
exactly. You need to be able to have some table and some and you can't like it just like there's also an issue of like you can look at the numbers pretty fast, but you cannot have you have a 10-page description of how a model behaves, and you need to compare 20 models. You're gonna spend a lot of time going through all of that.
Yeah.
So let me kind of like try to kind of make this question a bit more grounded. And let's say you're tasked, from now on, from the next couple of years, you're tasked with evaluating or having an evaluation pipeline for something like Bing chatbot. How would you go about that? Or what would your approach be?
You would create some bank of interesting questions. Interesting could be randomly sampling. You probably want more diversity than randomly sampling because that's going to have too much popularity bias. So you probably want to consider rarer things in some way. So you see there's already some sort of understanding what the model will view as rare, or, it's already, not well defined. But you would try to get some queries or questions of this flavor, and you would judge answers to them. So I guess, yeah.
With humans?
Well, the scenario is not so well defined that I know exactly what I'm doing. So I don't know if I'm judging retrieval or the answer output, or but this is the general flavor,
I guess
right?
It's more like an open, you have a system, what would be the kind of evaluation ingredients?
Yeah. So you need interesting cases. These are interesting questions.
One really good point already mentioned is you would favor diversity over over random sampling or
with random sampling, you're going to get the more popular ones. Right, so there's no solution to how you do this, I guess. I think it's very unclear, but you want to include a lot of stuff, right? You want, weird Harry Potter questions, you want medical questions, you want what movie was playing last night questions, just these are all popularity bias things you can see, but
And I guess the other leading question is do you look at some kind of dashboard numbers, or do you have a team of people that kind of looked at kind of sometimes kind of looks at case by case things and tries to spot spurious kind of failure cases or
I think you have to create the dashboard, because otherwise you would have no basis to say anything. Even if the people look at cases, they're adding up numbers in order to count how many times this one versus that one, right? That's just a different metric, the way I look at it.
So everything is metrics.
Well, if they're looking at cases, they say which model won. So that's not computing MRR, but you say this one or that one, you add that up, and now you have a metric, right? You know how they compare. But I think this failure analysis is important also. I guess I'm just saying I wouldn't base what I do entirely on the failure analysis. It has to be aggregated to some way to get a view of how they differ.
Yeah. Of course, it's an ongoing question. Nobody knows what's the best way to do this, but I think it's still very interesting to sort of think about.
Otherwise, you can just keep beats of what we said now.
We can do another one on our LHF even if we want.
Maybe
and then we
read
read, and then for that we read Instruct GPT.
Let's just think. We had a bit of a discussion on the effects of RLHF. But it seems like too big of a tangent to include in this podcast, so we might just do some kind of follow up and how that relates to information retrieval. Okay, let's just go a little bit into have a bit of a conversation about what the future looks like, or what we think the future looks like. I guess the biggest question is, how do you guys think the space of commercial search is gonna look like in the near future? Is this type of interface chatbot gonna take over everything, or is the kind of good old traditional query list of documents type of paradigm gonna stay?
That's a tough one.
And these are also two extremes, right? If we think about even current Google, you have things like these panes where it shows you a question someone else has asked, and then you can pull the pane down, and then it shows you a snippet it extracted that it thinks answers the question. They often do. They do not always. So I can imagine things like this, right? Integrating the chatbot into search more, but replacing entirely retrieving documents, I hope not, because I want to know what document the result came from. If attribution is done perfectly, I don't even see this actually as something different. It's changing the UI. It's giving me those links in a different way. But if it's still giving me the links, I don't know how to think about it.
For me, it changes, because if it attributes and answers your question correctly, you don't actually need to read the document. And I think that's a bit sad.
But you need to read the document in order to determine if it answered it correctly.
Maybe unless you trust it.
But you can at some point maybe it's just so good that you can trust it.
Maybe, but for something I care about, if a human tells me, I still don't care. I still read the citation they gave me, or I say, I don't believe you, give me a citation. So I think there's something similar here where information has to have some provenance in order to be trustworthy.
I guess that's the point that I mean, I totally see how you would probably be a person who cares about provenance.
I'm perhaps not the standard.
Exactly, I'm not so sure you're the standard user. I do fear that, right, that like a lot of this attribution and like it might also change how like publishers think about, you know, like publishers, how incentives like for people to click on their websites, blah blah. If suddenly Google can answer, or any of these web search engines can answer questions directly, people don't click through pages. It's a big shift in like how the whole economy of search and ads.
Yeah, well, there are also interesting legal and policy issues here. Like, why should we allow this? Just change copyright law so they have to pay the people they took the information from. Like, why should this?
Yeah, I mean, there's one solution which is already used for printed documents in a lot of countries. Like if you use, for example, your law practice and you use you scan printed documents, there's an association of law printed documents, national association.
Okay.
On a voluntary basis, you if you have written something, you submit a request. You say, I wanna be part of that big bucket of law books that should receive money because of that. This is how many pages I wrote. And then whenever someone scans, and then of course you cannot know, you can, as a law practice, you can approximate how much you scanned. You have no idea what you scanned, right? So what you can do is what they do is they say they force the law practices to report on what's the approximate number of pages they scanned during a whole year. And then on a pro rata basis, they have to pay to the whole bucket. So they pay
okay.
And then the whole bucket is redistributed, and that's the problem, equally to all the members, depending on how many pages they wrote. So it's not proportional to how many times it was scanned, it's only proportional to the number of pages.
Yeah.
And maybe there is something similar that's going to be built up, because it's a similar problem. You don't always know where the information comes from.
Mm-hmm.
Yeah, it breaks business models. It's fine if you send someone to someone's website, right, and then that website makes money through the ads. But the other case is sort of as you're describing, right? There's no business model for the person providing the information without this.
Yeah. And lastly, I think something that you guys may kind of reflect on is, I see a lot of people, I don't know how if that's true or not, kind of a little bit freaking out about what is the place of NLP research in a world where companies are making GPT-4s, right, that seem to basically crush any other benchmark out there. And I feel I'd like to relate that to like back in the day when Google became very popular and was doing web search, how that affected the IR community, how like history has kind of like how did they maintain complementary sort of research agendas or like interests in terms of like resources and data sets and blah, all of that. So how do you think the space of how do you see the space of NLP now, and how does it relate to kind of the history of IR in terms of like industry versus academia?
Yeah, maybe one meta comment first. So everyone interested in NLP, it's something to get excited about if you think a system has been solving what you're interested in. So I understand how this could be stressful from the perspective of like a student who they're worried that they won't be able to complete their dissertation. But in general, if you care about NLP getting better, it's great. Like, what's the issue? Like, who cares, right?
Just go on holidays.
Right? So either it didn't get great and you don't care, or it did get great and you're happy that it's better. But either way, but yeah, I mean, I think IR, as you said, like IR has been around for a long time. Like in web search, we academics maybe use web search type collections sometimes. So like there's a new ClueWeb 22. I don't know the number of terabytes offhand because there's a lot of different sizes, but it's order of dozens of terabytes. But this is not necessarily the most common case. There's all sorts of other types of search that people would do research on. So for example, product search or learning from interactions, as people interact with product web pages and that sort of thing, is all like a very active area of academic research. And this is just totally different from web search, right? You may not even have much, if any, text at all. If you move to like a more recommendation type scenario, maybe you have a little. So I guess I would say that it's hard to do web search as in IR, or not even hard to do web search, but hard to build your own search engine, just because this is hard for everyone because crawling the web is difficult. But there's plenty of other problems to focus on where people can make a lot of progress. So like conversational search is maybe a really good recent example where this is just a new paradigm. You see this happening, things like Alexa and Google Home now, Alexa, Siri. But like this is the questions here are all things that are easy to understand in an academic setting, right? So how do you incorporate the context? What is the role of different initiatives? Like how can the agent ask a question or try to shape the conversation in some way that improves the information need? So I guess you can argue large language models are doing a lot do this now.
Yeah, so you could argue that you can prompt your way through that.
Maybe, but why is that bad? So I care about solving conversational search. I can do it with prompting. Great, I solved my problem, something new. Yeah.
And I'm just interested in your perspective as a PhD student. What you see, like, what do you think you can still do meaningful work in this context?
Yeah, I didn't choose NLP as a topic, and I think a bit on purpose because I did feel like there was very much. I started my PhD in 2020. There was very much of bigger is better situation there. So I always try to find something where it's not too much explored yet. Like for example, now with diffusion. But I think even in the bigger is better paradigm, there is still some stuff you can find with either you append things to these models, you make it do more things, either with prompting, with reinforcement learning, but that's more in the fundamental domain, is like inefficiency, right? Like even if you feel desperate about the fact that you're a pure NLP person and you're desperate about the fact that GPT-4 is so good, it's good, but it still needs to read the entire internet, and humans don't need to read the entire internet to pass a law exam way better than ChatGPT. So there's still something where, what is that thing? Is it because of multimodality? Is it because of we as humans have a concept of what it is to hallucinate or not? There's a great essay, I forgot from whom, it's called On Bullshit. It defines what is bullshit. It's really good. Like bullshit is about like when you say, so what is telling the truth? It's when you say something and you want the other person to think the same thing you have in your head. Saying a lie is when you say something and you want the other person to have the opposite of what you said in their head. And saying some bullshit means you just say something, you don't care what the other person thinks of what you have in your head. You just want them to have an emotion reaction to it. And yeah. So I think it's super interesting also in that context of hallucination. Yeah.
Right, I think this conversation could go on for hours, and it's super interesting. But in the interest of time, we have to end it here. Once again, check out the workshop on generative IR that's gonna happen in SIGIR in July. There's the links in the description or the podcast description. Yeah. And yeah, thanks for your attention, and see you in the next one.
Thank you.